Welcome to Physics Skills, Formula Rearrangement, the examples that go along with Assignment PS2. Before you substitute numbers into an equation, we have to isolate the variable we are looking for first. You've already done this with some simpler formulas, but there are some more difficult formulas that we will be working with in the next 2 weeks. In the first example, we want to isolate HF. HF is on this side with mghf plus half mvf squared. Now, as mentioned in previous classes, we kind of treat HF as someone who has been trapped inside a building that has collapsed due to an earthquake. We don't just grab onto its arm and start yanking. We have to pull away the debris first. So that means I start with the things that are furthest away from HF on that side, which would be half mvf squared. Since it is adding, to move it to the other side, I'm going to subtract it from both sides. Since I have plus half mvf squared subtract half mvf squared, those two will cancel out. And that will leave me with mghf on one side. mg is multiplying by hf. The opposite of multiplication is division, so I will divide both sides by mg so I can get mg away from hf. Now that mg is on the top and the bottom, the two will factor each other out, leaving hf by itself. This could be considered the finish point, but this could be further simplified because I can see that mass is located in multiple terms on the left-hand side. I can take m out as a GCF. Now I have an m in the numerator and an m in the denominator, which can factor out. That will further simplify my equation. So HF equals GHI plus half VI squared subtract half VF squared all over G. Example 2. Total energy is equal to potential energy plus kinetic energy. So ET equals mgHF plus half mVF squared. I want to isolate M. I see that M is located in two different spots, and I can take it out as a GCF. Now M is being multiplied by GHF plus half VF squared. So to get rid of it, I will divide both sides by that big chunk of stuff. So now on the right-hand side, GHF plus half VF squared on the top will factor out with GHF plus half VF squared on the bottom. Now I have M isolated. So I'll rewrite the equation. M equals total energy divided by GHF plus half VF squared. The brackets in the denominator are not necessary, but if I'm going to enter numbers into my calculator, I will want to make sure that I do bracket the entire denominator so that my calculator knows that I'm dividing by the total number that's on the bottom. Example 3, I want to isolate VF. Again, I want to make sure that I start with what's furthest away from VF. So VF is here. Way over here, I have mgHF, which is adding to the half mass velocity final squared. So I'm going to then subtract mgHF from both sides. So mgHF subtract mgHF means that those two will cancel out. I now have half mvf squared on the right-hand side. The next thing I want to deal with is this half. A lot of people say the half is multiplying by mvf squared, so they'll want to divide by a half. But easier than that, and what I think is preferred, I will multiply both sides by 2, because half is dividing by 2, and the opposite of dividing by 2 is multiplying by 2. So I will multiply both sides by 2. Note that on the left-hand side, I put in brackets because I have to multiply the entire side by 2, which means this 2 is going to have to distribute into the brackets. On the flip side, this 2 will distribute into the bracket. There's only one term there, and the 2 and the half will cancel each other out. I'll distribute the 2 inside of the terms. So that becomes 2mghi. The 2 multiplied by the half will get rid of the half, and that'll be subtract 2mghf. And on the right side of the equation, multiplying by 2 will cancel the half. I wind up with 2mghi plus mvi squared, subtract 2mghf equals mvf squared. Now the next thing I'll want to do is divide both sides by m. M on the top and m on the bottom will factor out, and that will give me just vf squared on the one side. I want to get rid of the squared, so I will square root both sides, and the squared and the square root will cancel each other out, leaving vf by itself. To further simplify, I could again, since I see mass is in all my terms in the numerator, I could take out m as a GCF. Now the m in the numerator and the m in the denominator can factor out, and I will end up with vf equals the square root of 2ghi plus bi squared subtract 2ghf. And that's it for our examples. You're good to work on PS2.